Hi, this is Neil with the Teen Advisory Board of the Glenwood Branch of the Howard County Library System, and in this video we're going to be building upon the foundation we laid in the last video on chemical bonding. Let's get right into it. So in this video, more specifically, we're going to be going over the three main ways you can express the makeup of a chemical compound. Now the first way you can do that is through condensed structures, and that's the simplest way you can do it, and it's just a really simple way to do it. I'll explain in a second. Then there's also structural formulas, and those are a little bit more difficult, but they really build off condensed structures very well, and they'll build off what we went over last video, which is Lewis dot structures. And then the final way to do it is by line structures, and those are a little bit more complex, and we'll spend a little bit of the next video going through that as well. So condensed structures are the simplest way we can write out chemical compounds. And what they are is just writing out the number of molecules that exist in the compound. You just write them out, how many of carbon, how much hydrogen, how much oxygen, how much is in that compound. And so for example, propane, there are three carbon atoms, and there's 8 hydrogen atoms. So we put the carbon, C, and we put the number in the subscript, so that's the 3, and then H got the 8 for the 8 hydrogen. And condensed structures are good when you're dealing for simple compounds. When you get to more complex and unconventional compounds, it's best to have other tools at your disposal, such as structural formulas or line structures. And I'm going to get into structural formulas right now. Alright, so structural formulas are a more efficient than condensed structures, but not the most efficient, those are line structures, way of expressing chemical bonds. And they're really best used for these sort of middle-ish, I guess you want to call it, complex compounds. And with structural formulas, we're going to use lines and letters to symbolize or show the location and bonds between the different atoms in the compound. Now, let me give an example of this. With propane, we know that it has a condensed structure, or it has the makeup of 3 carbons and 8 hydrogens. So how it's going to arrange itself, and using a structure formula to show that, is with 3 carbons all bonded to one another, and then the hydrogens are going to sort of, I don't know how you would call it, fill in the blanks. They're just going to make everything stable. So they're going to have 3, because they're going to have 3 hydrogens on both ends, and 2 hydrogens in the center to give the carbons 4 bonds and to give the hydrogens 2 bonds. And we know that they want this because in the last study we discussed how carbons have 4 valence electrons and hydrogen has 1 valence electron, so hydrogen wants 1 bond and carbon wants 4. Now let me get into line structures. Alright, so starting off with line structures, I cannot stress how important it is that we have to really drill this in, that carbon, it wants 4 bonds, and hydrogen wants 1 bond. That is super important. Now, line structures is where we use lines to represent carbon atoms. And what we're going to do with those lines, after we sort of figure the initial stage out, and this is going to make sense, I'll show you an example, is we're going to fill in these sort of missing bonds with hydrogen. We're just going to assume it's hydrogen, and we're going to fill it in with hydrogen, because that's usually what carbon bonds with mostly in organic chemistry, is carbon and hydrogen together. It's in a lot of stuff. So what I just drew was a really just simple line. So at the ends, we're going to see carbon, and the line itself represents a bond between those carbon. Now let me draw another even more simple thing to show the other part of it, which is the ends, they're all with carbon, and the middle, or the intersection point, that's also a carbon. So I can actually sum up. The ends and the intersection points of the lines are all carbon, and then what we do is we use hydrogen to fill in the missing bonds in order to make the compound stable. This is super important. Remember, 4 bonds for carbon, 1 bond for hydrogen. If you forget this doesn't make sense to you, none of this is going to make sense at all. So let me get into an example. So I've drawn out pentane, which is C5H12, and I've drawn out its condensed structure and its structural formula. Condensed structure C5H12, structural formula, that web of of C's and H's. And this is just and pentane is basically propane, just with a little bit more carbon and a little bit more hydrogen. It's the same general structure and idea of carbons with hydrogens attached to them. And so let me get to line structures. So the first step in converting this structural formula to a line structure, because they're very, very closely related, they're basically built off each other, is we're going to get rid of all those C's. We're going to draw upon what we talked about in the last slide, where the endpoints and intersections of the lines represent carbon. And let me just draw on the H's so you can see. So it's really the same thing, just instead of writing the C, we just leave it out and we just continue the line. And let me fill in all the C's so you can still see that they're there, and that's where they would be and that they match up. So the reason we do this is to get rid of a lot of the extra information that we're going to see, and let me get into that once I show you the completed line structure. It'll make a little bit more sense. So the final step in converting the structural formula into a line structure is to sort of discard all of the written out hydrogen bonds. So we just have that sort of, I guess, two mountains, what do you want to call it? And that is the line structure of pentane. And the reason we do this is when we have these giant chemical compounds, chemical compounds get really big. We have these giant chemical compounds, it's much less hectic to show that, and it makes everything a lot easier to read. So what have we learned in this video? Let's review. So we've gone over condensed structures, which are basically where you just write out the number of molecules present in a compound. And then we moved on to structural formulas, where you use lines and letters to show the bonds and relationship between atoms in a molecule. And finally, we went over line structures, which are basically structural formulas with less upfront information that are used when you have more complex chemical compounds that you need to relate the diagrams and structure for. Finally, I'd like to give you a big thank you for watching this video. I know it was a lot of information, and I'd just like to say thank you so much for watching. I'll have another video explaining this a little bit more coming soon.